Good afternoon, everyone. So, in today's session, we try to solve a dynamic problem. So, dynamic programming interview question. So, we extracted some important question before it, heading toward the interview. So, these are the questions that are related to the first. First one is like coin change problem, then partition, best time to sell, buy and sell stock. These are like one of the important questions before you solve interview, understand all this topic, all this like what is inside this one. Okay, the first question that is based on coin change 2. Okay, so we have to remember what is the first question, that is coin change 2. So it is a lead code question, is hard, so just you can search on the lead code question number like 518. Okay, so let's see what's the inside the question. So first of all, in this the problem explained that you are given an array of coin and domination and an amount to find a number of combination that's make up that amount. Okay, and you have unlimited number of coins. So and that is the amount are given with us like 5 example wise, and the coins are given like this one. Okay, 1 2 5. So these are the amount we want to achieve, and these are the unlimited point we have. And so how many ways we like do this one? So the first thing is first thing come in our mind is that, so we can do by first of all we can take the 5 value. Okay, by this one we achieve, by this one we can achieve 5 the R amount. So this is the first way, and another way is that we can use 2 plus 2 plus 1. Okay, by this one we reach to the 5. So second way, and we another way is that 2 plus 1 plus 1 plus 1. Okay, this 2 is equal to 5. Okay. So one more is this will also become 5. So this is in 3 way, 1 plus 1 plus 1 plus 1 plus 1. So this is 3 to 5, 3 plus this one 5. So in this one we can see that by 5 ways, by 4 ways we can achieve this amount. Okay, how can we do? Okay, so first of all, this question is from the dynamic programming because it gives us choices to select this number. So either we can choose or skip this one. So in that case, if you have the choice, then use DP. Okay, so key observation is we need number of way, not the minimum coins. Okay, so we need just number of way. So this is a kind of question of this unbounded knapsack DB problem. Okay, so first of all we have to maintain the states, all this thing. Okay, so how we write the code? First of all, we try to solve in the recursive manner. So let's see. So what are the things we have to maintain the states? For maintaining the states, maintaining the state, what you have to do? So first of all, for the step is equal to the states are we have to solve function in which we have indices in which we are moving, and this amount we have. Okay, these are two steps. We are currently on the index coin index, and we need to make the remaining amount. So these are the, and we have to return the number of ways from this one coin. Okay, so for that one, so let's see the base cases. What are the base cases if we have? So if amount becomes 0, so if amount becomes 0, So what we have to do? So if our amount is equal to 0, in that case we have to return 1. Okay, in that case we have to return 1. Okay, so found only valid combination, that is 1. Okay, and what if no amount left, no coin left? So no coin left, no coin left. So this is the second case when no coin is left. So in that case what we have to do? If we reach to the idx is equal to that coin dot length. Okay, so in that case we have to return 0. So we reach to whole coin and we don't find that sum up or like individually make that amount. Okay, so still amount remain, no value is. So this is the base case. Okay, this is what we call base case. Okay, and let's see what are the choices. Okay, so how we make choice? So the first thing, line line. Okay, so first of all we draw a line, and the first thing is that the choices we have, how we make choices. So for the choices we have to this one, and the choices we have. So okay, choices, for the choices we have to choose, so we can only choose if the coin of that idx is uh, less than that amount. In that case we choose that coin. Okay, or less than or is equal to, and then after that then and if we take, so we can write like solve. If we take that, we have to remove that amount. Okay, so idx is same, we don't change that, we can have a limited choices. So in that amount, okay, amount we minus that coin and add that idx. Okay, this is the logic. Okay, and if idx remains same, because it will be idx remains same because we have the unlimited coin choices. Okay, if we not take, then in that case we have to move this idx. Okay, and that amount remains same, so this is the choice, and then move to the next point. Okay, so like a number of ways. So how we number of find the number of ways? So like take plus not take, by this one we find. So this is the logic, we find the base case, what are the approaches, and let's write the java code. Okay, java code for this one. So let's write. So java code for, first of all we write, have to write in like, okay, so first of all we have this class solution, you have class solution we have, and this private, in which private like we have to return integer. Okay, and this private, like no, wait, so we have to write like this is the recursive code. First we have to write the recursive code. Okay, So like so in that case public class solution inside this we have like private public choices for the integer that we call as a changes. So in this we have amount, okay, amount we can set as this one, and this we have the integer of coins, okay, of coins. And so in that case we have to simply return the solve function. So solve function in which we have like starting from zero index we like give this nums dot. Okay, and the amount we have to like give, and that and the coin array, okay, coins we have, okay. This is the upper main thing that we have to do. And after that in like private we have to write this one, what is solve function. Solve it return the integer, okay, solve it return integer, so we write this one. And in that integer what we have, first of all the index, and this what is index, which is where we are moving, and then amount and this like integer, it is coin, okay, coins. So okay, and it's if we take, so we know the base cases what we have, right? Like amount of zero is equal to 1 if it is this one. So for this one we have to see this thing, okay. See the first recursive code of this one, this is Java. So let's see. So in that place we are writing, so instead we're doing this one, so we have to paste, okay. So this is the Java code for this one. So we see that private int solve we have integer, okay, array. So if the like base case is if the amount becomes 0, so we return the 1, okay, because we reach to the solution, okay. And if we move to the end of this index, so in that case we don't find that number, so in that case we return 0, okay. For the taking, so first of all initialize this value, okay. If that coin of index is less than the amount, in that case we use recursion like index amount minus and coin dimension. If not take, so this is the like simple recursive code, okay, recursive code, okay. Take, not take, and the sum, the value and the answer will be take, not take. So this is like the case of this one. And we have to like use memset for the like memOS, do this one. So doing a memoization in this one. So how we do? So for this one, the two things are changing. This one, use memset instead of use memset. So like in Java there is no memset, so we have to use top bottom approach. Okay. So let's see, the top bottom approach is this one. So where we paste. Okay. So this is the top bottom code. So first of all, we have to what we have to first get, we have to like fill the DP. Okay. So first of all, we have to like two things are changes. So like first we initialize the 2D DP. So this one, like this thing. Okay. Java.util dot array. So Java.util everything we can pass. Okay. And this is the initialization of 2DP in solution first of all, okay, and this is like the main code, like main function which we have amount and the coin. So like this DP we initialize this DP new integer, okay, in this we have like the length of the coin IDX move, and we have to add extra one amount. So this is the initialization of DP, and we fill all DP with 0 so value. So starting from, so how we fill DP, so like how we fill, let's see, like instead of doing this one we can also do like for auto over rows, okay, and over this DP. So array dot fill rows -1. So let's skip this part. So we are filling this one, so like 0 to coin length till we have to fill all this value is equal to -1. So array dot fill at each of this index -1. So array dot fill DP of this one, DP of I is equal to -1, okay, and then we have to return this one solve function. So this array initialize, like a DP initialization part will be done in this section, okay, we did it, and rest of remains same. This base case remains same if amount equal to 0, if we reach to the end of this code, and if that is not -1, if DP of that IDX, I have to write like, okay. So if so if DP of that IDX, okay, IDX and that amount is not equal to -1, this means that there is some value for this one. So in that case we have to return this DP of this one, okay, or integer take, so same value, okay, solve inside DP, like all this thing, not solve, improvement this one, and we store all this value inside the DP of that inside and that amount, okay. So this is like memorization code, top to bottom code, okay, like initializing the DP. So DP is equal to new integer, we have to put in this value, and array dot fill DP of I is equal to -1. So in this way we have to do the question, okay. The first question we solve, okay. I think this question take approx 17 minutes. So try to solve the another question. In that question, we understand at the base case what are the thing logic, and we solve like recursive and the memorization way. So like solution. So we did it. So I have to write not practices. Done. Okay. So in that case, done. Okay. So at the last, we have to visit this one. Okay. So partition equal subset. So like partition equal subset. Okay. So for the partition the equal subset, let's move to this question. Okay. So second question. Okay. So like get thicker. Okay. Second question. So we have to solve. That is based on partition equal subset sum. Okay. So like partition. So partition. And you can find this question on LeetCode. Question number is 416. Okay, and we try to solve in Java. Okay, for the better practice. So this is the one of the most important question of the 0-1 knapsack. So this is a variation of 0-1 knapsack. Okay, knapsack. Okay, so how we solve the first of all the problem is given with this, like we are given an array, determine if it can be divided into this subset having the equal sum. So we understand that we have some array, okay, 1 5 1 5 1 11 and 5s, all these things, okay, and we have to divide into two like equal subsets. So we can do this one. So we can do this or not, okay. So we use like 5 5 1 as a one part and 11 as another part. So we can do this one. So we have to return true for this case. So true for this case, okay, true for this case. So how can we do? Okay, let's see. So our approach is that like we have to divide this array into this one. To divide this array into this one. So okay, for this one we can write it as the 11 alone and then 1 5 and 5 together. So this will become a same. So this look like, so these two values look like same, okay, and having containing. So we can partition that equal subset. So what are the approaches? So what are the approach I have to do? Okay. So like some like calculating all these things, some things we had needed. If we have like two equal subsets, so we can do. Okay. So first of all, we have to like calculate all this value before dividing anything into parts. So first of all, check if it is divisible by 2 or not. Okay. So this is our first case. This is our the first case. We have to check. So you have to uh, check whether we divide the array sum by 2 or not. Okay. So first is the like, can we make this one? Okay. So if it is odd, so the sum if sum is odd, so in that case we can't divide. We can't okay, divide. Okay. So this is the main logic. Okay. So it is a pure recurrence in which we move on each index and what is our target. Okay. So the for the target, okay. And can we form the target using? So what we have written, can we form the target or not element? So this is like in case we have to written Boolean thing. Okay. The base case is that if target equal to 0. So like it divide, so it become some give a value. So like sum of all the sum of nums give some value. So give some value x, okay, and the target is equal to x by 2, okay, and we want to find the target. So in that case, the base case is equal to solve, and in that solve, what we have to check, we move the index idx and we want to reach our target. Okay, so it like a 0 1 knapsack thing. Okay, so first is the base case. First the base case is that we if we reach our target. So if the target is equal to 0, so if target is equal to 0, in this case we have written true because we did it. Okay, if we like move to the like found the valid and like found a valid subset. So if I move to the end of this index, okay, nums length, okay, so in that case we move to the end. In that case we have to like return false, return false. So in that case we have written false. Okay, so no element left to do this one. Okay, so this is same as earlier code. Okay, let's see the code. So recursive code for this one, first of all, we have to like initialize a sum. Okay, we initialize this sum. Okay, and we do the sum of all this number for auto int over nums sum this one. If sum is not divisible by 2, then in that case we have to return false, otherwise we have to do this one. So this is the index, this is the target we want, and we pass this nums array. Okay, so these things are cool. Okay, so we in this case we have to return this one. So write the logic for the private like boolean, this solve function. Okay, this is a private boolean. So first of all, this is the index and this is the int target. Okay, for this one. Okay, sum is the integer of this one as a num. Okay, the base case, if the target becomes 0, in that case we have to return true. If we reach to the end of this nums array, so in that case we can't find any value which make or sum up as a target. So in that case we have to return false. Or let's initialize our take. So like take is not an integer. Okay, take is a boolean, so take as a false. Okay, if our nums is less than target, so in that case we take the value. Okay, solve, take this value, and in that case it is not in infinity number, so we have to take and move. So I plus 1, and we like minus the value and then return. And not take is also in a boolean value, so not take is a boolean not take. And solve function, we increment from that value and the target remains same, we like not minus anything. Okay, we find if any of this value give a true, then in this way, so it is a true. Okay, like two things are changing, index and the target is changing, so we like for the memset function we need 2ddp. Okay, okay, 2ddp, what we have to do. So first thing is that what we have, this particular set, what is inside memset value. Okay, okay, these two things we have to see. This is a recursive way. So in recursive way we need to like 2ddp. Okay, like 2ddp. Okay, so how we manage like integer double bracket, we have to like array for creating 2ddp. Okay, and this is dp. So the logic is same, sum int, how we do sum. So first of all initialize the sum value. Okay, and check if sum is not divisible by this one, return false. Okay, if a target is equal to like sum divided by 2, so dp is equal to what, this new and integer. So first of all we find the nums dot length and target plus 1 value we have to include in this thing. Okay, and this 2ddp is created and we have to fill this one. So like integer for auto insert, for we like consider as the row over dp. So array dot fill this all these rows with -1. So like initializing all the element with -1 in the 2ddp, and we solve for the we write the solve function for this one. So we see that in private boolean solve this function, we have in the index for this one, target we have a value, we have like nums array. Okay, so the same, if target becomes 0, so we reach to our solution. So in that case we have to return. Okay, in that case we have to return true. If we reach to the end of our index, so in that case we mean that we don't find that particular number, so to reach like sum of that value as a target. So if dp of case, return dp of this is equal to 1. Okay, so in last case like return dp, so in that case we have to return this is equal to 1. So this is equal to 1, this means true. Okay, and again a slash take to the same condition, not take, and this one. So answer will be like take and not take. So answer will be fill. So dp of is equal to answer. If answer is true, in that case we fill 1, otherwise we fill 0 and then return the answer. Okay. This is what we have to do. Okay. We solve two question based on dp using it. So I want to think 1 second. Okay, so welcome back once again. So after this break, so we have to solve the third problem that was based on. So this question is also done. Okay, so we are solving two question as fast as we can by understanding all this topic. So like best time to buy or sell, like we have to solve. Best time to buy and sell stock 4. Okay. Okay. So let's solve this problem. So like third question. This one is the like best time to buy and sell stocks. Okay. Okay. So four, and this one is a four, and we can see lead fourth question as a 188. Okay. So it's question number three. It is question number three we are trying to solve. And the question is that you can complete at most a transaction. Okay. So one transaction means buy or sell. Okay. So like buy and sell mean is equal to one transaction. So in this question we have to complete a K transaction. Okay. And you cannot hold multiple stocks simultaneously. Okay. So let's see the inputs what we have. Okay. So in B, K is equal to 2 and the prices of the each stock is equal to, so we can make at most K transaction, that is K, and the prices are given like 2, 4, 2, 4 and 1, 4 and 1. Okay. And so, and find the profit on all these things. Okay. So like if we buy, so if we buy 2 and sell 4, so in that case we have a profit of 2. Okay. So in this, like we are moving on this index. Okay. Buying and selling the state and this transaction, how many transactions are left. Okay. So we see that we have three index moving, buy and sell things. Okay. States, and how many transaction, K transaction we have. So we have to maintain these three states. Okay. So we have to see how we do. So in thing in this thing we have to say like we have three states. Okay. Can say if we have three states to maintain, that is like, okay. So in this we have to maintain like solve function inside the solve function. Okay. In solve function we have like to maintain the index. Okay. Index buy or not buy, or it if we buy or sell, so we have maintained. And how many capacity we have, like how many times we have. Okay. So index where we are, so like IDX and explaining that we are the current day, we are like current day. And in buy, if we buy anything, then in that case we have to like this one. And if buy, then if buy is equal to 1, so this means that we can buy this one. Okay. If buy is equal to 0, so in that case we understand that we can like sell, must sell this thing. Okay. And cap mean that we have to like a transaction remaining, so transaction remaining. Okay. How many transaction we have, so we have to print. And the output we want, what we want, maximum profit from this state. So profit maximum profit from this state. So this is all about the question, this question. Okay. So can do this one. Okay. Like great. Okay. So this is all about the question. So how we insert this, how we insert like rectangle inside this one. This is what we can't make a rectangle, so instead of we do this one. Set this one. It needs some dark background, so like blue. So we can this is the question we are like wasting the time. So what are the base cases we have to notice? So base case we have to like focus on. First of all, if our index reach to the end position, like end, like price dot length. Okay. So in that case, we return zero. So we didn't earn anything profit. Okay. I think if no day left, like no depth left. Okay. Like if transition is completed. Okay. So if cap is equal to 0, in that case we return 0. Okay. If cap is 0, so in that case also return 0. Okay. Understand? And choices. If buy allow, then buy the stock. Okay. So if I buy the stock, okay, if I buy the stock, this means that we are at the loss. So like when we buy the stock, so we pay that money. So that's why we have write this like IDX. Okay. And plus we move to the next state. So solve. So like IDX plus 1, we we buy, so we want to like sell, and this capacity remaining. Okay. The capacity will remain, because if after buying selling, that capacity will become -1. Okay. If we want to like skip this thing, so we simply skip this thing. So we like simply write solve idea x plus 1. Okay. And we like didn't buy anything, so instead of buy, and capacity remain cap. Okay. Okay. This is the case. And then take the maximum. So like buy and sell all this thing. And this is the case of buying. This is a case of buying. Okay. And we have to explain about what we have to like sell. If we want to sell, so in that case we have to earn that price. Okay. Earn that price. We earn that price and move to the next. Okay. And IDX. Okay. IDX plus 1. And now we want to buy, so we have to like 1, and the transaction is completed. If you this one -1. Okay. If you want to skip this portion, so like simply, so in this is skip this portion, like IDX plus 1, and we still want to like sell, so this will be 0 and capacity become cap. Okay. So this is the whole logic for this one. Okay. Let's see the code. Okay. Okay. So let's see. We want like recursive code. Recursive code. Buying or selling the stock, we want like recursive code. So let's see the recursive code. So we have this recursive code. Much big. Okay. So recursive code for this one, simply we are trying like integer. Okay, this one, like we have k number of transaction we have, and the prices, how much prices values. Okay. So in that case, we starting from 0 and 1 indicate that we want to buy, k prices remain, k transaction is remaining, and this prices array we have. Okay. This private index, so integer for this index for this one, buy or sell for this one, k for the capacity, and the prices is equal to this one. Okay. Okay. So if this is the base case, if we reach to the end of this price array, okay, in that case, or if the capacity becomes 0, if any of these two cases occur, so this in this case we have to return 0. If buy is equal to 1, in this case, if we are trying to buy something. Okay. So if we take that value, we have to decrease our value by -1, because we have some, we put our money to buy anything. So in that case, we put that minus. Okay. So if we buy, then we next step is to sell. So in that case, we move to the next index, and we try to sell this one, and the capacity remains same because we don't sell that thing. So after selling, it become -1. Okay. And all this remains same. So if we don't buy this, and we want to skip this thing, So in this, we simply increment the index array, all things remain same. And this case is still is equal to 1 because we want to buy. If you want to buy, then it will become 1. Okay. And what we have to return in this case? So we have to return the math dot maximum from this take or not skip. So we return this value. Okay. Else if you want to like sell, in this case we want to buy. Okay. If we want to like sell, okay, so in sell we add this price because this is our profit. Okay. Okay. So in this case we increment this index. In future we want to buy, we decrement the capacity of transaction. Okay. And in this case we simply increment this, want to like sell anything. In this case we also find the maximum of like return or sell of this thing. Okay. 1 second. So hello, sorry for the disturbance. And earlier we see that recursion, by recursion we see that how we do, but and when we have to maintain this thing in this top-down approach, that is memoization. So like in memoization we have to, like, first of all we have three things that are changing. That is that is our like our index are changing, whether we are buying or selling, and we are also checking our like capacity, or we also seeing for our prices integer. Okay, so this remains same. For that one we have to initialize the 3ddp, okay, integer 3ddp, okay, 3ddp. Okay, here we are. So we created the 3ddp. Okay, in this first of all we see this integer. Okay, 3ddp, how we initialize. First of all, n is equal to price length for this integer. Okay, this is clear. After that we created uh, this dp, that is dp is equal to new integer, and we have to put in that in two sizes, because we only need one or zero. Okay, and this is the size for integer, and we increment this size by k plus 1. Okay, and how we fill this value? So we want to fill this dp, by this process. Okay, by this process, auto 2ddp over mat of this one, again auto it row over this mat. Okay, and array dot fill row is equal to -1. Okay, by this process we fill 3ddp. Okay, and 0 and all this thing. So like this is the main task we have to do. Okay, after that all this thing, if it is not is equal to -1, then return same thing. If you want to buy, do the same process. Okay, and in this case dp of idx of by cap all this thing, math dot max from take and skip, and again dp of this one is equal to math dot max of this buy and sell and skip. The this is like easy question, buy and sell stock 4. Okay, I think that we have solved the three question. This one is a hard one, but we have solved this question too. So this question is done, and then we move to the third question, that is maximum like minimum path sum. Okay, for the minimum path sum we have to see what is the minimum path sum question. So these are the three questions we have solved. Okay, and the third question, third question, that is third, sorry, third is fourth one. Okay, so fourth one, that is based on minimum path. So like minimum path sum. Okay, and this lead code question is 64. Okay, so let's see how we solve this question. First of all, we are given with say m cross n matrix. Okay, so this is grid, and to fill with a non-negative integer. Okay, number we have to find from the top to bottom, right? So this is the grid if we are talking about. So if this is the grid, this is the grid. Okay, this is the grid. Okay, and we want to reach to the bottom right side. So bottom right side is this position, okay? And if from starting from this top left, so like we can move only right and down. So we have only two choices to at every cell. So two choices every cell, and we want to reach in the minimum path sum. So it's some value like 4, 6, 2, 3, 1, 8, 9, all this value. I want to reach at this position by taking the minimum path sum. So like simple, it's simple, where we have to like choices. So at every step we have to think. So recursive thinking is that at every cell we have to go right and down, and we have to choose the minimum path. Okay. For this one, so the state maintenance, like set states look like solve, in which we have two choices I and j. Okay. And we want like minimum from this one. So what are the base cases? Think base case we think. So base case will be like when we like reach at the end of this one. So if I reach to the m minus 1 and and j reach to n minus 1, so in that case we reach to the end of this one. So in that case we have to return like grid of I and grid of j. What are the value inside this one? Okay. And if we like try to move outside this one, like invalid case, if I is equal to m or j is greater than is equal to n, in this case we try to like to move outside this one. In that case we have to return this invalid thing. So like integer I capital integer dot max value. Okay, value. Okay. And this is the invalid path. Okay. Or if you want to move on the right side, so for moving the right side we have to like right side. So if we want to so this we have I for moving on this direction, j for moving on this column direction. So if you want to move on the right side, so what we have to do? So in that case I remains same, and j is plus y 1. Okay. If you want to move down, so in that case down is equal to solve this function I plus 1 and j remains same. Okay. And finally return grid of I or j is updated by, we are not grid I and j. I and j is equal to sum of this one. So like minimum of this one. So math dot mean of this one, right, comma, down. So from this one we can find the minimum path of this thing. Okay. So let's see the recursive code for this one. This one. Let's see the recursive code. Okay. Okay. So let's see the recursive code. So first of all, we have to find this row size and the column size. Okay. So we find the row size and column size, and we are starting from like we're starting from this like end of like we are starting from this end. Okay. So in that case, we are starting with the end. So no issue. Like either we can start from the bottom or it's like from the top. Okay. And we find okay this one. If we reach to the like top of index, then we have to index this one, because every value are stored in particular index. If we try to move outside this particular value, so in that case like we have to return some garbage value. Okay. So integer dot max value. Okay, any value. If you want to move up, so so in that case we have to do minus, because if you want to move up and it's starting from this position, so this position, if you want to move up we have to minus 1. Okay. If you want to move right side, So we add plus. If we move left side, so we minus this thing, okay? And we find minimum path from this one. So like math is equal to mean up and up comma left, okay? So by this one we can find the minimum path, okay? And if we want to solve using this recursion, this is like we are like two states are changing, right and like right and I or j, okay? So in that case the recursive code like memoized course will be look like this one. So for this one we have to initialize 2d dp, okay? 2d dp, this is the grid dot length, okay? dp will be established by this one integer m comma n, okay? And we fill this value with the -1, so int row dp over an array dot fill row -1, okay? And we will starting from the bottom, okay? When we reach to the top we return this value, okay? Otherwise we have to return some garbage value. We check if that dp is exist, in that case we return that dp, otherwise we add sol plus, like we adding that dp sol plus, we are moving to the left side, sol plus we move to the left side, and finally stored in the dp the minimum value of this one, okay? This is what the minimum path sum for question, okay? We solve the 4 question, we solve the dp 4 question on this one, so we understand that logic, okay? We understand the logic and we solve the 4 question. So in the like next another session we try to complete this all the question. So thank you for joining this session, okay? In like further session we solve more different data structure question. So we understand whenever this question give you choice to choose this path or this path, in that case you have to use dp, okay? So let's end this session. Goodbye.